Okay. For this learning unit, we will discuss about the basic estimation technique that normally we use to estimate the relationship between the dependent variable and independent variable. So mostly we discuss about the technique from linear perspective. Okay, the first thing that you need to understand and to know is the parameter. Okay, I believe that you have learned the words of parameter or the terminology of parameter in statistics course. Okay, so the parameter is all about the coefficient. Okay, the coefficient is an equation that determine the exact mathematical relation among the variable. So in a simple language, we can describe the parameter is all about the magnitude. Okay, the magnitude here is the value that normally we refer to measure how straight is the relationship among two variables that we want to explore. Okay, so the parameter here actually is numbers, and we can construct the construct or to calculate the parameter using simple mathematical technique that I believe that you have learned in the statistics. Okay, and then when we talk about the parameter of the coefficient, it's very close to the technique of regression analysis. So the regression analysis is a statistical technique for estimating the parameters of an equation and then testing for the statistical significance. So in the first lecture during the class, I've discussed with you, I've shown you the graphical illustration to show the regression derived from the idea of the straight line, and then we had tried to apply the theory of demand function and the supply function, how it can be applied in economic theory. So as I also have briefed you about the terminology of dependent variable and the independent variable, or independent variable also can be also referring to the terminology of explanatory. So the dependent variable is a variable whose variation is to be explained. Okay, meaning to say that the dependent variable depends on the independent variable to explain its characteristic. The explanatory variables or independent variable is, in other words, we can call it as the determinant, okay, the determinant factor of dependent variable. Okay, for simple linear regression, as I told you, the simple linear regression is adapt the theory, not the theory, the concept of the straight line. From the straight line, we can, how can I say, we can rewrite in mathematical term as y equal to a plus b x, or y is the dependent variable equal to a is the constant coefficient plus bx. Okay, bx is the independent variable, and then the b is the parameter for the independent variable. So as I told you, a is the constant variable, and I've given you the example. What does it mean by constant variable, when we need to put the constant variable in the model, and when we should not consider the constant variable in our model or in our estimation. And then the b is the coefficient, the parameter is the parameter to explain the value of x. Okay, that's what we call as parameter. So that's why we have slope. So the straight line here has a slope, or in other words, as I told you in the class, we had a good understanding on about uh, what do we call as the elasticity, right? The slope itself has some mathematical term that we need to understand. Okay, regression line shows the average or expected value of y for each level of x. So how x influence y. So how dependent variable influence y. But then, for your information, we need to highlight here that the prediction here is not an actual relationship, but at least we have some basic information about the relationship between x and y, or the relationship between dependent variable and the dependent variable. Somehow we will look further throughout the course later. How can we justify that our regression, our mathematical term is near to actual environment or not? We will look through some other tests to confirm that the regression that we have developed is perfect, or in statistical term or econometrical term, we call it as the our regression is in a good fit. There is a law, and there is a law that we need to confirm that our regression is in good fit. And then we will talk about the random error too. Since we use a sample, multiple samples, and then we also deal with the outlier data information, then there is the existence of random error, or error term that we need to understand. Okay, error term is something like an unobserved term. Example, I've given you the example of the demand function. Okay, if we are using the demand function as our baseline theory, so there is a factor beyond the demand function. It's like the family background, the demographic behavior, the demographic environment that is not uh, that is not that factor actually is not being concerned in the demand function. But then the value or the behavior of that thing we call is as unobserved term, because we just focus on the demand function, not the other social factor. So the other social factor will be parked at the random error. Okay. So there are a few nature in regression analysis. The first one is the time series. Okay, the time series is actually when we have an information, a series of information by year, by month, by quarter. Okay, and we also have a cross-sectional nature. The cross-section nature does not involve any series, so we're just talking about what is happening in that particular period. We are not looking in the previous, what had happened yesterday, on what will happen in the future. So the cross-section is all about what is happening now. So we are not looking what had happened yesterday. But time series, we are looking what had happened yesterday and how it relates to what is happening today. That's the difference. Okay. And nowadays we have another term of another nature of data. We call it a data set. We call it as a panel data analysis. I think you will learn further in economic modeling next semester. Okay, fitting a regression line. Okay, as I told you, a method on this script, there are we can compute the parameter. Either the parameter is a constant parameter, or the parameter is the from a part of independent variable. So there is a technique to make it fit. a good, this is what we call as a good infit. Either we want to reduce the value of standard error term, or else we want to improve this the outlier. So the outlier here is referring to the value of standard deviation. If let's say the standard deviation is too big, okay, it means that the observation that we have is very far from the mean value. So there is something, there are some events that we need to look further that actually can disturb our estimation. Okay, this is what I mean. Okay, if let's say this is the, actually this is the step that we need to follow in order for us to uh, come up with or to compute the parameter. I believe that you have learned in the statistics. This is just a recall. I just want to recall you the step that we need to go through. But then in this, for econometrics, normally we are not going to do step by step anymore. We just straightforward to use the software that we have in this new moment. And then now it's actually our skill to elaborate the finding. Our skill to understand what does the parameter means for us. Okay. As I told you, in the end we have this. As I told you just now, the uh, the value for constant and the value for b is not to say an actual information to represent, to explain to us the subject that we want to explore. It is just a prediction. Okay, so the word of prediction here, we will look further how can we prove that our prediction is effective or efficient, or in mathematics, or no, in uh, statistical language, or in econometric language, we call it as a good infit. Okay, so let us look at uh, this illustration. So the dot 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 here is our observation. From our way of from the observation that we have, regardless we are referring to the data from a type of time series or a type of cross section. Okay, and then actually we can since we have two variable here, example like here we have sales, and another one we have advertising expenditure. We have two variables here, right? Let's say else is our y, our dependent, and then x is our independent, is the advertising expenditure. Then we can construct, then we can how can I say, we can compute the parameter. As now example, in the slide here, we are able to construct the value for constant, and also we also can construct the value for uh, uh, parameter for independent variable. So now these are the thing that I'm what this is the thing that I want to mention to you about error term E here. Okay, if let's say the estimation to say that in this level the prediction of cells is 46 when 46,000, but then in actual actually jump to 60k. So the difference between 60k and 40k, 46k is the error term. The error term here is means that when we just looking at the factor that we are considering in order for us to compute our estimation, it contribute about 46k. But there are other factors to contribute to more than the value, more than that, but then unobserved. It is considered as an unobserved. So here actually there are two perspective or narrative. The first one, the difference between 60k to and 46K is referring to inefficiency in our estimation, because there are other factors that we are not taking into account when we are computing our regression. The second one is that there's nothing wrong with this. There's nothing wrong with the gap, because the gap here is actually the thing that we do not want to know. That's the thing. So it depends on the study. It depends on what narrative that we are looking for. Okay. So that's why that's why I told you just now, the value for parameter is actually not a true values. There are other factors that we need to consider, especially when we looking at the pattern of the random error. Okay, and then we will look through on this. The distribution, actually, this is the normal distribution. If let's say our distribution graph is not like this, meaning to say that we have an outlier data that we need to look through. The outlier data or information here is referring to the the error term. Okay, this is just to recall you back the what we have learned in statistic course. Okay, you need to come up with a hypothesis, and then from that hypothesis, then we can come up with the story. The hypothesis is very important for us to elaborate or to conclude the the information given by the parameter. Okay, so we can use t-test or p-value, but for me t statistic is enough rather than the p-value. Okay, this is the basics step when we are developing our hypothesis. It's exactly the same as what you have learned in statistics. Okay, the T, as I told you, the T here, you need to be careful if you want to compute manually. That if let's say the T here is referring that if your study is referring to the sample or the population, that's the thing. Your observation is from sample or the population, that's the thing. Because the formula for us to compute the T depends whether our observation is from sample or the population. Okay. Again, when you compute the T, the degree of freedom is very important. Since now we are discussing on a simple statistic, then nothing much to be worried with the degree of freedom. But then if let's say we are discussing about the multiple regression, then the degree of freedom is much more important for us to understand. Okay, the p-value is actually derived from the t-test. And then in econometrics, we are not looking on how to compute the p-value from the t-value. Okay, another term. Now we are just now we have discussed about the parameter, and the term that we need to understand here is R square. The R square is talking about the fraction of total variation in the dependent variable that is explained by the variation in X. So in other words, how many percent X can represent Y? This is what it means. Okay, if let's say we will discuss more in practical letter. If let's say the R is 0.9, it's referring to 90% of X represent Y. This is what it means. Okay, it can be at range 0 to 1. So 1 equal to 100%. So high R square indicate Y and X are highly correlated and does not prove that Y and X are causally related. Okay, so but then somehow if you use time series analysis or data, definitely R is high. If you use a cross section, R quite low. So other test that you need to concern is F test. F test is in a layman term we call is a test to investigate How about a chain of factors to cost dependent? This is what it means. Okay, so the F test can be done when we are doing the multiple regression. Okay, for the behavior of multiple regression is in line with the simple regression. The difference between simple regression and the multiple regression is just multiple regression have a lot of factors, a lot of independent variables in one regression. So during the class later, I will show you how can we illustrate in in graph. So we from that we understand what is the difference between simple and multiple regression, and then how can we synchronize it, harmonize it, so that we can apply it to explore the subject that we want to know further. Okay. Other than multiples regression, we also have quadratic regression. The quadratic regression is more to non-linear. So as for now, no need for you to know the non-linear regression up to until you know the factor to contribute the goodness of fit of the model. So I just want to mention you, quadratic is non-linear, the non-linear, uh, the non-linear regression. So it is not when we construct it, when we try to transform the information, the regression in graph, we find that it is not in the term of straight line, not in the straight line nature, but it is more to non-linear like U shape or inverted U shape. Okay, so we also have log linear or log linear. Sometimes we need to use log linear if, let's say, the factor that we want to explore have a large value, okay, or different unit, then we need to perform a log. But then need to be careful with the way we explain it. Okay, so we will go through this later when we are going to have our tutorial during the class. Okay, okay. In summary, it's all about to know the relationship between two variables, and then to know how the strength in mathematical term about these two variables, and also we want to know the goodness of fit because we are dealing with the algorithm. Okay, so we are going to have the what do we call as the hands-on activity during the class. Then I believe that theoretically it is quite difficult for us to understand, but when we go through the practical exercise, hands-on exercise later, you can understand further. That's all for today.